Welcome to an exploration of the final frontier, where we delve into the challenges and possibilities of creating artificial atmospheres on other planets. This topic isn't just about science fiction, but about the very real, very complex science that could one day enable us to live beyond the confines of Earth. So what is an atmosphere? It's the layer of gases surrounding a planet that are held in place by gravity. Earth's atmosphere is made up of nitrogen, oxygen, argon, and traces of other gases, and it plays a critical role in sustaining life. It regulates temperature, protects us from harmful solar radiation, and provides the air we breathe. But what about other planets? Could we create artificial atmospheres that mimic these life-sustaining conditions? The short answer is, we're not sure yet, but we're certainly trying to find out. Creating an artificial atmosphere is a monumental task. We're talking about altering the very fabric of a planet, changing its climate, its weather systems, and potentially even its gravitational pull. It's a challenge of cosmic proportions, but that's what makes it so exciting. In our quest to create artificial atmospheres, we're not just aiming to mimic Earth. We're looking to understand the fundamental processes that make a planet habitable. This includes understanding the chemical composition of atmospheres, how they're affected by solar radiation, and how they interact with the planet's surface and magnetic field. But why would we want to create an artificial atmosphere? Well, the answer lies in our enduring human desire to explore and expand beyond our own planet. The ability to create an artificial atmosphere could allow us to colonize other planets, to create new homes for humanity in the vast expanse of space. In the following sections, we'll dive deeper into this fascinating subject, exploring everything from the atmospheres of different planets in our solar system to the potential use of greenhouse gases, to the concept of terraforming. As we embark on this journey, let us first understand the atmospheres that currently exist within our solar system. Our solar system is a diverse assortment of atmospheres, each with its unique challenges. Picture a cosmic buffet, each planet offering a different flavor of atmosphere, from the scorching heavy air of Venus to the thin, freezing expanse surrounding Mars. Let's begin with Mercury, the planet closest to the Sun. It virtually lacks an atmosphere, leaving its surface exposed to the harsh solar radiation and extreme temperature variations of space. Now imagine trying to engineer an atmosphere here. Moving on, we have Venus. Its atmosphere is thick with carbon dioxide, and surface temperatures are hot enough to melt lead. The atmospheric pressure here is over 90 times that of Earth, akin to being a kilometer underwater. Creating a breathable atmosphere here would be no small feat. Then comes our home, Earth, with its oxygen-rich, life-sustaining atmosphere. It's the gold standard, the model we'd aim to replicate on other planets. Next up, Mars, with its thin atmosphere of mostly carbon dioxide. Its lack of a robust magnetic field allows solar radiation to strip away its atmosphere, a challenge we'll delve into later. Jupiter, Saturn, Uranus, and Neptune, our gas giants, are primarily composed of hydrogen and helium, with trace amounts of methane, ammonia, water vapor, and other compounds. Their atmospheres are incredibly thick and turbulent, with crushing pressures and violent storms. Finally, there's Pluto, a dwarf planet with a thin, tenuous atmosphere that freezes and falls to the surface as it moves away from the Sun. As we can see, our solar system presents a wide range of atmospheric conditions, each offering unique challenges for creating artificial atmospheres. Some are too thin, others too thick, some too hot, others too cold, and some composed of gases fatal to humans. Understanding these atmospheric differences is key when considering the creation of artificial atmospheres. They provide us with a clearer picture of what we're up against as we dream of making other planets our own. Remember, to conquer the cosmos, we must first understand it. Mars, our neighboring planet, provides a fascinating case study for the creation of an artificial atmosphere. Known as the Red Planet, Mars has intrigued scientists for centuries, and now we're looking to it as a potential new home for humanity. The Martian atmosphere is vastly different from our own. It's thin, primarily composed of carbon dioxide, with trace amounts of nitrogen and argon, and it lacks the oxygen that we humans need to breathe. This thin atmosphere means that Mars is much colder than Earth, with an average temperature of minus 80 degrees Fahrenheit. That's colder than the coldest recorded temperature on Earth. The thin atmosphere also means that Mars doesn't have the same kind of protection from solar radiation that we have here on Earth. This presents an enormous challenge for any potential human settlers. Without a substantial atmosphere, we would be exposed to harmful solar radiation, and the pressure would be so low that our bodily fluids would start to boil at normal body temperature. But challenges are made to be overcome, right? That's where the idea of creating an artificial atmosphere comes in. If we could thicken the Martian atmosphere and increase its pressure, we could potentially make Mars more hospitable for human life. And there are a few ways we could go about this. One possibility is to release greenhouse gases into the Martian atmosphere. These gases could trap heat, raising the planet's temperature and thickening the atmosphere. Another possibility is to build artificial habitats, enclosed environments where we could control the atmosphere and temperature. These habitats could be a stepping stone, a way for us to live on Mars while we work on transforming the planet as a whole. The red planet, with its thin atmosphere and cold surface, presents a challenge that scientists are eager to tackle. As we continue to explore the cosmos and push the boundaries of what's possible, Mars stands as a testament to our ambition and our curiosity. It's a challenge, yes, but it's also an opportunity to learn, to grow, and to reach for the stars. And one proposed solution to Mars's inhospitable environment is the use of greenhouse gases to warm and thicken its atmosphere. To transform the thin, cold, and dry atmosphere of Mars into something more habitable, we could look at greenhouse gases. These gases, such as carbon dioxide, methane, and water vapor, trap heat from the sun, and could warm Mars's surface, making it a bit friendlier for human life. But where would these gases come from? One option is to release them from Mars itself. The planet's soil and polar ice caps contain a significant amount of carbon dioxide that could be freed through heating. Additionally, if we could establish factories on Mars, we could produce powerful greenhouse gases like chlorofluorocarbons, which are thousands of times more effective at trapping heat than carbon dioxide. However, this raises the question of the environmental impact. On Earth, we're combating the adverse effects of excessive greenhouse gases. On Mars, we'd be intentionally producing them. This presents an ethical quandary. We must ensure that our efforts to make Mars habitable don't inadvertently create a runaway greenhouse effect, turning Mars into a sweltering hothouse like Venus. This is where terraforming techniques come into play. Terraforming, the process of deliberately modifying the atmosphere, temperature, surface topography, or ecology of a planet, moon, or other body to be similar to those of Earth, could be the key to creating a livable environment on Mars. One such technique is to introduce photosynthesizing organisms such as cyanobacteria or algae to Mars. These organisms could not only generate oxygen but also help to sequester carbon dioxide, regulating the greenhouse effect. Another technique is to create artificial magnetic fields. Mars' lack of a global magnetic field is one of the reasons for its thin atmosphere. By creating artificial magnetic fields, we could protect the atmosphere from solar winds, enabling it to thicken and warm up. While the concept is promising, it is not without its challenges and ethical considerations. As we venture into the cosmos, we must tread carefully, balancing our ambition with responsibility, ensuring that our footprint in the universe is one of exploration and growth, not exploitation and destruction. If altering an entire planet's atmosphere proves too daunting, we could consider creating smaller, controlled environments. This is where the concept of artificial habitats steps into the picture. Instead of transforming an entire planet, we focus our efforts on constructing self-contained environments that mimic Earth's conditions. A bit like building a mini-Earth on another planet, if you will. These habitats could be designed to regulate temperature, circulate air, and even produce food and water. It's a bit like creating a biodome in space, a self-sustaining ecosystem that could be home to future space explorers or even colonists. Imagine stepping into a dome on Mars and finding a lush green jungle, or a serene beach right there under the alien sky. Now let's take a leap from the surface of a planet to the vast expanse of space. Space-based solutions could also be a part of our toolkit for creating more habitable conditions on other planets. This might involve deploying large mirrors to reflect sunlight onto a planet's surface, warming it up, or using sunshades to cool a planet's atmosphere by blocking out some of the sun's rays. These solutions could help regulate the temperature and conditions of a planet's atmosphere without the need to alter its composition dramatically. But, as with all things space-related, these concepts come with their own set of challenges. The construction and maintenance of artificial habitats or space-based structures would require significant resources and technological prowess. not to mention the logistical complexities of such large-scale projects. Yet these approaches, while ambitious, may be more feasible and less ethically fraught than large-scale terraforming. They offer a way to create pockets of habitability without drastically altering the natural state of a planet. After all, space exploration is as much about understanding and preserving the cosmos as it is about expanding our horizons. So whether it's a biodome on Mars or a giant mirror in space, these artificial habitats and space-based solutions could be our ticket to making other worlds more livable. It's a bold vision of the future, but then again, isn't that what space exploration is all about? These approaches, while ambitious, may be more feasible and less ethically fraught than large-scale terraforming. Creating and maintaining an artificial atmosphere would require a significant amount of energy. This isn't just a simple task of flipping a switch or planting a few trees. We're talking about altering the very air of an entire planet. To put it into perspective, consider the energy required to power a city like New York for a day. Now imagine needing that amount of energy every second, for years on end. That's the kind of power we're talking about. But where would this energy come from? One potential solution lies in nuclear fusion, a process that generates immense amounts of energy by combining light elements like hydrogen. Fusion is the same process that powers our sun, and it's clean, sustainable, and virtually unlimited. But there's a catch: we haven't quite mastered it yet. The challenge lies in creating a controlled fusion reaction that produces more energy than it consumes. But researchers around the world are making strides in this direction. Another option could be space-based solar power. Imagine vast arrays of solar panels in space where the sun never sets, beaming energy back to our terraforming projects on the surface. It sounds like science fiction, but the concept is theoretically sound and has been seriously considered by scientists and engineers. Yet, these grand ventures won't be achieved by any single nation alone. The scale of these endeavors necessitates international collaboration. Just as the International Space Station is a joint effort of multiple nations, so too would be the project of terraforming another planet. This collaboration could not only share the financial and resource burden but also foster a sense of global unity and shared purpose. However, such cooperation comes with its own challenges. Differences in national interests, regulatory policies, and technological capabilities could all complicate matters, but with a common goal and mutual benefits, these obstacles could be overcome. The energy demands are high, but the rewards could be astronomical. Creating artificial atmospheres on other planets would be a monumental achievement, marking a new era in human history. It would not only expand our horizons beyond Earth, but also offer a testament to what humanity can achieve when we work together towards a common goal. Our ambitions need not be limited to our solar system. Exoplanets offer exciting possibilities for creating artificial atmospheres. In the vast expanse of the universe, countless exoplanets, or planets beyond our solar system, are waiting to be discovered and studied. These celestial bodies present us with a host of opportunities and challenges. With advanced telescopes, we are able to detect these distant worlds, many of which may have conditions suitable for sustaining life, or at least the potential to be altered to do so. Creating artificial atmospheres on these exoplanets brings its own set of unique challenges. The distances involved are astronomical, and the variability of conditions on these planets is far beyond what we encounter in our own solar system. The technology required to reach these distant worlds, let alone alter their atmospheres, is currently beyond our grasp. But as the saying goes, necessity is the mother of invention. Our endeavors to create artificial atmospheres align seamlessly with broader goals in space exploration. It's about more than just survival. It's about expanding our understanding of the universe, pushing the boundaries of human potential, and perhaps even ensuring the long-term survival of our species. As we seek to become an interplanetary and perhaps even an interstellar species, we must also consider the ethical implications. The alteration of planetary atmospheres is no small act. It is a grandiose intervention on a cosmic scale, one that requires careful consideration of its potential impacts and consequences. In this grand venture, international collaboration is indispensable. The exploration and potential terraforming of exoplanets is a task too monumental for any single nation to undertake. It demands the pooling of resources, knowledge, and expertise from across the globe. The challenges we face may be immense, but so too are the opportunities for cooperation and shared discovery. As we forge ahead, we must remember that our endeavors are not just about reaching out into the cosmos, but also about looking inward, reflecting on our place within it. As we learn to adapt to new environments, we may also gain deeper insights into our own planet and learn how to better care for it. The creation of artificial atmospheres represents a bold step forward in our quest to become an interplanetary species. It's a testament to human ingenuity and our ceaseless quest for knowledge and exploration. The challenges are formidable, but history has shown us time and again that we are a species of explorers, innovators, and problem solvers. As we reach for the stars, we may find that we're not just exploring space, but also shaping it. Our influence, our footprint, extends beyond our own planet, reaching out into the cosmic ocean. And in that vast expanse, who knows what incredible discoveries await us? The creation of artificial atmospheres represents a bold step forward in our quest to become an interplanetary species. As we reach for the stars, we may find that we are not just exploring space but also shaping it.